The stars were once upon a time of paramount importance to the ship's navigator. An aspiring ship's officer would have to demonstrate a good level of understanding of celestial navigation and the ability in using the stars to determine the position of his ship. Hi, I'm Captain Roy and welcome to my channel where I make videos and answer questions about ships. So if you would like to know more about ships, then stay tuned. Come on board with me. But in recent times, with the compulsory requirement for ships to have electronic navigation using electronic charts, GPS, and satellites, celestial navigation has taken a bench seat as substitute. Electronic navigation systems provides highly accurate positions in real time. It eliminates the need for paper charts and the manual plotting of positions and has become the primary mode of navigation for ships at sea. In this age now, navigation is no longer about position finding but more about the safety of navigation. Henceforth, the only time when it will become necessary to engage celestial navigation on board for position finding is when there is an electronic failure or damage in the ship's navigation system. In such a case, celestial navigation will come in handy if there is no other way or means of obtaining the ship's position. And for what it's worth, the heavenly bodies are also still useful for checking the error of the ship's compass while at sea. Henceforth, for these reasons, it's still a necessity for deck officer students to have to learn it when attending nautical school. In celestial navigation, all that is needed is a pencil, a piece of paper for calculations, a plotting sheet or paper chart, parallel rulers, the nautical tables, sight reduction tables, an accurate chronometer, and a mechanical instrument called a sextant, which is an instrument for measuring angles. These equipment are still carried on board modern-day ships. So how does a navigator go about using the stars in celestial navigation to determine his position? Apart from the sun, moon, and planets, 57 stars are available for celestial navigation. The altitude and the bearing of these stars can easily be extracted from the sight reduction tables. The officer will need to select 3 to 4 stars from the tables. It is best to select the bright stars with mid-range altitudes. Once selected, he can then go about preparing to make an observation using the sextant. Importantly, he should check the sextant for any possible errors such as the index error before using it. Once ready to start, he begins by setting the altitude of the selected star onto the sextant. The next step is to go out and face the horizon and by using the ship's compass, point the sextant into the direction of the star's azimuth as given and observe the star through the lens of the instrument. This is called taking a sight. Sights are normally taken during the period of twilight. This is when the sun has just set but it's still bright enough to see the visual horizon and dim enough to see the stars appearing in the sky. When taking the sight, the sextant must be adjusted so that the star just touches the visual horizon. Then by rocking the sextant, the star should be observed to be in tangent with the visual horizon. As soon as this is achieved, the exact time in hours, minutes and seconds and the angle reading on the sextant must be noted. After the sights for all the 3 or 4 stars that were selected is completed, calculation work can then begin. The concept used in calculation is the celestial sphere concept. Basically, this is an imaginary sphere that's in the sky which coincides with Earth, and all the heavenly bodies are on it. In this concept, we have to adopt the ancient ideology that Earth is in the center of the universe and that everything revolves around us. But because the Earth's axis is tilted, the Sun will appear to move around the Earth on the celestial sphere in a path called the ecliptic. The Earth's equator, when projected on the sphere, is called the equinoctial. Parallel of latitudes projected on the sphere are called parallel of declination, and longitudes are called hour angles. An observer's position on Earth is known as the zenith on the celestial sphere. All measurements are angular and thus part of the sphere, and henceforth, mathematical spherical trigonometry can be used for calculations. There are several methods available for position finding, but in this video, I will discuss the 2 most commonly used methods, the Marx-and-Hilaire or intercept method and the meridian passage. The Marx-and-Hilaire method. In this method, the objective is to obtain a position line by comparing the difference between the true altitude that was taken by the sight and the calculated altitude of a heavenly body. The difference is called the intercept. The first part is to correct the sextant altitude that was taken into true altitude, which is the altitude of the heavenly body measured from the center of the sphere. When doing this, corrections of parallax, refraction, and dip must be applied. And finally, the true altitude can be found by solving the triangle AOB when the external angle SAB equals the sum of the interior opposite angles, which is simply angle AOB plus angle ABO. On the celestial sphere, the true altitude translates into the zenith distance ZX of the triangle PZX, where P is the pole, Z is the observer's zenith, and X is the heavenly body. The next step is to obtain a calculated value of the altitude. This can be done by using an estimated position, commonly referred to as the date-reckoned position, or just DR for short. The calculated zenith distance can now be compared using the true zenith distance that was observed earlier using the sextant, and the difference is called the intercept. If the value of the true zenith distance is less than the calculated zenith distance, then the intercept is plotted towards the body. And if it's greater than the calculated zenith distance, then the intercept is plotted away from the body. Finally, the true bearing of the body must be obtained, and this can also be calculated, or it can be easily obtained using the ABC tables that's included in the nautical tables. The navigator can now use his DR position and proceed to plot the intercept and the bearing of the body to obtain a position line. Basically, this means the ship's position can be anywhere on that line. Usually, when all the 3 position lines are plotted, they should all cut at a single point if the site was well taken. This point then constitutes to be the observed position of the ship and is called a fix. Now let's move on to the next method, which is called the meridian passage. The name meridian passage implies the passing of the body over the observer's meridian. In this method, the objective is to obtain the ship's latitude and finally the ship's noon position. The first step in this method is to take a forenoon sight of the sun, normally at about 10 a.m. in the morning. The intercept method, as explained earlier, can be used for this sight. The next step is to wait till the sun nears the observer's meridian. This happens close to noon time. The navigator then uses the sextant to observe the sun as it nears his meridian. Through the lens of the sextant, the sun can be observed to be rising in altitude as it nears the meridian, and the sextant should be continuously adjusted so that the sun remains in tangent with the horizon. When the sun stops rising, that means that meridian passage has occurred, as the sun is now exactly on the observer's meridian, and the reading on the sextant and the exact time should be noted. Upon passing the meridian, the sun will now start to set, and its altitude can be seen to be decreasing. This means that the meridian passage is over. The observer can now proceed to calculate his position. Here the calculation work is much simpler as the sun is on the meridian, which means the position line obtained thus equals latitude. All the navigator needs to do now is to transfer his earlier forenoon position line to the time of noon. Where the line cuts the latitude obtained from the meridian passage, that point is the ship's noon position fix. Using these methods, the ship's position can be obtained at least 3 times a day, one at morning twilight, one at noon, and one at evening twilight. Such was the mainstream way navigators sailed the oceans before the advent of satellites and global positioning systems. Well, once again, we've come to the end of the video. Thank you very much for watching. Hit that like button and subscribe. And I wish you a great day, and I'll see you